In the previous video, I mentioned that the Pi hat is where all of your custom sensors and actuators are going to plug into. So in this video, I wanted to dive into a little bit more detail of what capabilities you have in the Raspberry Pi hat and what you can connect up to that. So let's zoom in and take a little bit closer look at the connectors that we have available to us. So along the right-hand side here, there are 16 servo ports. So a servo, if you're not familiar, I'm referring to an RC hobby servo. An example, I got a picture of one right here. This is an example of what a servo looks like. These are typically used on radio-controlled airplanes. It's just a motor that can be used for things like grippers or moving a camera around or positioning some sort of manipulator or parts of an arm for moving for moving an arm or a gripper around. So there's spots to plug in up to 16 of these servos. One thing I should point out is the power supply chip that powers these servos is limited to 4 amps. So you can get servos that are huge, that can move huge loads, but this board's power supply isn't capable of powering really big servos or lots of really big servos. So you do have to be careful about how many servos you use and what you use them for. For example, making a giant heavy robot arm that is powered by RC servos probably won't work because your arm, overall the servos are going to use more than 4 amps. So it's better to keep these in applications like moving a camera, which is a fairly light load, or opening and closing a gripper, which is a fairly light load. But using it for like a shoulder joint on a big heavy robotic arm probably isn't a good deal, isn't a good idea. We have other options for motors that could be used in heavy applications like that that I'll go into in another video. So those are the 16 servo ports. Next, let's look. There are 5 analog input pins, which are located in the middle of the board here. Might be a little bit difficult to see, but there's actually 3 rows of 3 columns of connectors. And if we look at these in rows, there's an analog pin, a power pin, and a ground pin. So that gives us five analog ports. Each port has an analog input pin and a power and ground pin. So these analog pins are good for measuring, hooking into things like analog sensors like thermistors for measuring temperature. There are short range finder sensors that have analog outputs. If you were needing to put on like a light sensor, for example, there's many of those that have analog outputs. These could be used for measuring signals from sensors like that. Next, over in the corner here, there are 5 digital input-output pins. These are connected directly to the Raspberry Pi, so you can access these from Python scripts. That's over in this corner right here. So these digital pins are good for doing things like interfacing to bumper switches, so you can tell if your robot's touching something. You could interface these to use these for controlling lights, like sending control signals to switch on lights or buzzers. They could be used for limit switches for detecting the position of a robot arm. Like their name implies, they're general purpose. Lots of different uses. Right below them in this picture are right here and right here are 2 serial ports. These could be used for making a serial data connection to a separate Arduino board, for example. These could be used for interfacing to things like LiDAR sensors that use serial ports. Their pins can also be used as general purpose input-output pins if needed. The same with this serial port called SPI0. This is another type of another type of serial port that could be used for interfacing to special sensors that have an SPI port. If you needed more GPIO pins, you could use some of these as well. Right below that we have these two I2C connectors. One of them is dedicated for the motor controller. If you were to add, it's possible to add more motor controllers. This is how you would add on more motors for doing like a robot arm, like bigger motors for a robot arm. They would daisy chain and hook into this I2C6 connector. But just keep in mind that this I2C6 connector should only be used for motor controllers. The I2C1 connector is is available for you and any custom sensors you want to add that are I2C capable. I2C is a type of serial communication. There's a lot of range finders and temperature sensors, GPS modules, things like that that could plug into an I2C port. Below that, this green 5 volt out connector can be used for supplying power to some of your custom circuitry. When the Raspberry Pi is turned on, 5 volts is available at this port. So this is the same 5 volts that is sent to the Raspberry Pi. So I'm 5 volt out. So don't apply power into this port. This is only an output port. So, and there's nothing to stop you from connecting multiple devices to this port as long as they're not using too much power. On one of my robots, I have a small fan connected to this that's cooling off the Raspberry Pi. So whenever the Raspberry Pi is switched on, there's power on this port and the fan is on. The last connector I wanted to point out on this board is these current drivers right here. So I'm going to go into more detail in another tutorial on to give examples of hooking sensors up to these various ports. But for now, I can just point out, just want to let you know, the current drivers are used for switching on devices that need a little bit of power. So this would be something like let's say you have a spotlight that you want for driving in the dark. Something like that uses more power than you could supply from a GPIO pin. You would use one of these current driver pins to supply that device that needs a little bit more power. This could be used for powering a laser module, like a laser pointer, or a light, or turning a fan on, for example, something like that uses more power. And I think that's about it for the connectors. Like I said, we'll have more tutorials that give a bit more detail on how to interface to each of these types of connectors in some future videos.